analysis of variance or the ANOVA for week 11.
Okay po, ma'am.
Before tayo mag-start ng ANOVA, kasi di ba sabi ko before, meron tayo iba't ibang distribution, yung like the Z distribution, the T distribution, K distribution, and the F distribution. Kasi yung F distribution natin is included siya or dapat alam mo siya before ka mag-analysis of variance kasi meron tayong F distribution na application doon sa discussion natin. And also, di ba, na-discuss din natin yung sa hypothesis testing, yung meron tayong null hypothesis and also when we have naman yung H sub 1, yun naman yung alternative hypothesis natin. So, gagamit pa rin tayo nun for the analysis of variance natin. And again, bago tayo mag-discuss ng analysis of variance, medyo papahapiwan muna natin tong F distribution because it is also included in the analysis of variance. Same with the Z distribution natin before, di ba may pinakita tayo na table para makapag-solve tayo and ma-determine natin yung value ng Z natin. And same dito sa F distribution, gagamit din tayo ng table. But first, let us discuss kung ano ba yung F distribution natin. So, for the Z distribution, gumagamit tayo ng normal distribution. And for the T distribution, halos ganun din siya pero hindi pa siya natin na-tackle. Medyo papahapiwan ko din siya mamaya. So, for the F distribution, yung una daw is, ano siya, F distribution is continuous and is skewed to the right. So yung graph niya, hindi siya normal distribution. Kung di ba meron tayo before, yung parang kapag normal distribution natin is paganto na siya. So normally distributed, equal yung left tsaka yung right natin. Pero for this, since yung mismong graph natin is skewed to the right, yung graph natin is medyo paganto na yung graph natin. Hindi siya yung parang same as yung dun sa graph natin dito sa normal distribution natin. And also, sabi natin dito, for the F distribution, it has two number of degrees of freedom. Kung before, hindi naman tayo gumamit ng degrees of freedom. When we discuss the Z distribution, yung mga dinetermine natin dun is yung standard deviation or the variance natin. And we have also yung mean natin and also yung sa sample size natin. Pero dito, additional, meron tayong degrees of freedom. And also, given dun sa table natin, we have yung DF for the numerator and also we have the DF for the denominator. Yun yung pinagkaiba niya. And also, the units of an F distribution naman is, dinadenote naman siya as F. Yun. So, for the Z distribution, Z yung ginagamit. For the F distribution, F naman yung ginagamit natin. Ito yung example ng graph natin for the F distribution and kung paano natin makikita yung sa table. So later, papakita ko to sa table natin. So for example, we have the DF. Yung first natin, which is yung 8, ito yung nagsisimbolize siya as the first number denotes the DF for the numerator. And for the next naman nating number, which is yung 14 natin, ito yung second number natin na nagde-denote for the DF for the denominator natin. Let's say, itong graph natin sa 12.1 natin, for example lang, we have here, itong graph natin na to, nagsisymbolize siya dun sa DF natin, na yung numerator is 1 and yung denominator is 3. And then for the DF natin, na ito yung graph natin, we have naman yung numerator as 7 and yung 6 yung denominator. Well, for the DF natin na ito yung graph, yung last natin, which is itong graph na to, we have yung 12 and 40. And we have yung table natin based dun sa dito. So we have yung critical values. So ito yung first natin na graph, which is critical values for 0.01. Ayan. Kung before sa Z distribution natin is we have, di ba, yung 100% confidence interval siya. Now, we have yung mga 0.95 na ginagamit or yung percentage, and then we have yung percentage din ng critical values. Dito rin naman, meron din naman siyang ginagamit. Again, for this graph, or for this table, we have yung 0.01 for the critical value. And kapag magbabasa tayo or paano natin gagamitin to, we have yung dito sa pinaka first row natin, itong row na to, ito is nagsisimbolize for the numerator. And yung second natin, itong first column natin, is nagsisymbolize naman siya sa degrees of freedom for the denominator. So, we have 4 tables naman. So, sabi natin, yung first nating table is for the 0.01 critical values. And for the next natin, is meron naman tayo ditong given na 0.025 na critical value. So later papakita ko sa iyo yung paano natin sinasolve. Parang same lang naman siya ng distribution. Medyo iba lang yung approach niya kasi iba yung table natin. And next natin is we have yung table for the 0.05. So yung una 0.01, next is 0.025, and yung next natin is 0.05 na table. And yung last natin na table is the, sobrahan. Ayan, 0.10 naman siya. Yung critical values natin. Nasa problem naman siya. And for example, ang given natin sa problem is 0.10. Ito yung gagamitin natin na table. Base nga ito dun sa mismong critical values natin. And yung last na table natin is for the 0.10. And kung papansin mo dito yung graph natin, ito yung concern natin. Itong graph na to, ito yung part ng 0.10 natin. So halos lahat naman ng graph natin is dito siya naka-include yung critical values natin. Nagba-vary lang siya or nag-iiba-iba lang yung value natin. Ayan. So ito yung example natin. So sabi natin for the first problem or the problem number 1, find the f value for 8 degrees of freedom for the numerator. And 14 degrees of freedom for the denominator. And yung given natin is 0.05 area in the right tail of the F distribution. So ang assumption natin, we have na, ito yung 8, diba? Sabi natin sa row, which is doon natin titignan yung numerator natin. And also naman yung denominator natin for 14. So ito yung column natin, which is yung 14. Parang z-distribution lang din kung ano yung katapat na value. Naalala mo, ganun siya.
Yes
yung,
po.
Ayun. So, same lang siya dito.
Yung sa table, ma'am?
Yung sa table. Oo. So, dito din, ganun din. Sa table lang din. Tayo magtitingin ng value. Sabi natin ang value natin daw is 0.05. So, babalikan lang natin yung table na meron tayong 0.05.
0.5.
Oo. Kasi di ba apat yung table natin kanina. And yung katapat na value niya, where we have yung numerator as 8 and denominator as 14, we have the value of 2.70. So, yun lang siya. Yun lang yung value nito based doon sa given natin na numerator and denominator. And kapag nag-graph tayo, yun. So, df, sabi natin yung first value is the degree of freedom for the numerator and the second value is the degree of freedom of the denominator, which is we have the 8 and 14. And yung mismong itong highlighted natin is the 0.05 or the critical value natin and the value for the f, which is 2.70. Okay, ganun lang siya. Ganun lang yung kung paano natin gamitin yung F distribution. Pero ito ay part lang siya ng ANOVA or the analysis of variance kasi ang focus ng discussion natin is ANOVA. Okay, explainan man natin si ANOVA. Ayan. Analysis of variance are also known as ANOVA, and it was developed by Ronald Fisher in 1918. So extension lang din siya ni T distribution at saka ni Z distribution. Before, di ba, diniscuss natin si Z distribution, which is yung formula natin for Z distribution is we have the x minus mean over the standard deviation over ng square root of n or yung sample size. And yung sample size natin is dapat greater than siya sa 30. While for the t-test, ito is hindi pa natin siya na-discuss, pero ang difference lang naman niya kay Z distribution, imbis na gagamit tayo ng sigma for the standard deviation, ang ginagamit natin is letter S. So for the formula for the t distribution, we have t is equal to x minus mean over s over nung square root of n. And since we have yung sa z distribution as we have yung sample size na greater than 30, for the t distribution naman or the t-test natin, ang sample size niya naman is, correction lang to ha, for the t distribution is we have the less than 30 naman. So for here, we have the z distribution greater than 30, while for the t distribution, we have the less than 30 for the sample size. And ang way nito,
kaya tayo gumagamit ng analysis of variance is to hypothesis testing naman siya for to test yung equality natin of two or more population. So later makikita natin yung mga classification for the analysis of variance. And then for the assumption, so same lang with the, kung mapapansin mo yung sa z-distribution na graph natin is also a normal distribution. So as an assumption for the ANOVA, we have that all populations involved follow a normal distribution and all populations have the same variance or the standard deviation. And last is the samples are randomly selected and independent of one another. So, yun siya. So, yun yung assumption. And then for the classification, so for today, ang discussion lang natin is until dito lang sa one-way ANOVA. Since covered niya naman yung week 12, for the week 12, we will discuss the two-way ANOVA and the n-way or the multivariate ANOVA. So for the one-way ANOVA, first is when we compare more than two groups based on one factor, which is the independent variable. Yun yung one-way ANOVA. So two groups lang siya. Like for the example we have here yung sa manufacturing company, ang comparison na gagawin nila is the productivity of 3 or more employees based on working hours. So meron lang tayong 3 employee pero ang comparison nila is sa productivity. So, doon lang siya. Yun yung example ng ANOVA, which is one-way. One-way pa lang siya. Well, for the two-way naman, for example, for the two-way, when a company wants to compare the employee productivity based on two factors. Kung kanina, ang ginamit lang natin is one factor, which is the productivity. And dito naman, we have the two-way factor, which is yung example natin dito is based on working hours and working condition. So dalawa na yung comparison natin based doon sa mga employees productivity natin, which is sakop na siya ng two-way ANOVA natin. And for the n-way, so yung n dito is more than na siya, more than ng 2. When the factor comparison is taken, it is said to be n-way. So for example, is the productivity measurement if a comparison takes all the factors for productivity measurement. So meron tayong comparison na ng productivity pero iba-iba na yung measurement natin. More than 2 na siya. Again, for the one-way ANOVA, so ito yung focus ng discussion natin. Una daw, so sabi natin kanina, di ba, ang ANOVA is with application of the F distribution and also with the application of the hypothesis testing. So recall lang tayo dun sa discussion natin before with the testing yung hypothesis natin. So kapag nag-hypothesis testing tayo and we have yung problem natin, yung worded problem natin, kailangan i-convert natin siya from word problem to mathematical problem na siya. Let's say, we have here the null hypothesis and also the alternative hypothesis. Null hypothesis for the H sub 0 and alternative hypothesis for the H sub 1. So ang assumption natin when we derive using this one-way ANOVA, yung first natin is we have the null hypothesis, which is we have yung mean natin or mean sub 1 is equal to mean sub 2 and so on. And syempre sabi natin, di ba, ang kabaliktaran ng H sub 0 natin is the H sub 1, which is yung kung equal lahat ng value natin for the null hypothesis natin, dapat hindi equal si alternative hypothesis. So dito, sa alternative hypothesis natin, ang assumption natin for this is at least 2 of the means are not equal. So we have na dito yung hindi na siya equal kasi nga yung null hypothesis natin is equal. And again, yun na. So we have here yung mismong kung paano tayo magka-calculate ng value of the test statistics. We have the value of the test statistics, which is yung F kanina, which is the F distribution for a test of the hypothesis using the ANOVA or the analysis of variance is given by the ratio of two variance. So we have here yung ratio for the MSB, which is yung variance between the samples, and yung MSW. So we have the variance within the sample. So for the test of statistics F, for a one-way ANOVA test, ito yung mismo magiging formula natin for the F distribution natin. we have yung variance between samples and also the variance between samples, or we can categorize it as MSB over the MSW. Okay? And next natin is, ito na yung sa problem natin, kung paano natin siya gagamitin. Basahin muna natin yung problem number 2 natin. For the problem number 2, we have 15 fourth grade students were randomly assigned to 3 groups to experiment with 3 different methods for teaching arithmetic. At the end of the semester, the same test was given to all 15 students. The table gives the scores of students in 3 groups. So, ang given natin for the method 1, we have the 48, 73, 51, 65, and 87. And then for the next method, which is the method 2, we have 55, 85, 70, 69, and 90. And then for the last naman, the last group, we have, or the method 3, we have 84, 68, 95, 74, and 67. And we need to calculate the value of the test statistics F. Okay, so step by step naman tayo. So for the solution, categorize muna natin ano ba yung mga nasa given natin. Yung for the solution, we have yung different terminologies na gagamitin natin for the analysis of variance. We have first, kapag daw we have the X, ito yung the score of the students or yung X natin. And then we will also use K, which is the number of different samples or yung treatments na ginagamit. And then N sub I, which is the sample of the size of sample I. And we also have here yung capital T sub I, which is equal to the sum of the values in sample I. And N for the number of values in all samples. Example nito is we have the N sub 1 plus N sub 2, N sub 3, and so on, based dun sa problem natin. And then we also have the summation of X, which is the sum of the values in all samples, or equivalent to the capital letter T sub 1, T sub 2, plus T sub 3. And we also have the summation of X squared, which is the sum of squares of the values in all samples. So medyo itong analysis of variance natin is masyadong marami siyang formula and medyo detailed din yung gagamitin natin. We will also use then, di ba, sabi natin kanina, for the computation of the F, we need to calculate yung MSP natin and also the MSW. Pero bago natin ma-solve yun, kailangan natin ma-determine muna yung between sample sum of squares natin, which is yung SW natin. And we also need to determine yung within sample sum of squares natin, which is the SSW. And also the total sum of squares, which is the SST. So therefore, we have yung formula natin na SST is equal to SSB plus the SSW. So the following values of SSB and SSW are calculated using the following formula. So ano ba yung mga formula natin na yan? So eto, for the formula for the SSB, ito yung formula natin. So kapag na-determine na natin, which is yung value natin for the T squared, yung mismo value natin ng T and then N, i-add lang natin siya, which is equivalent lang yung SSB into open parentheses, T squared sub 1 over the N1 plus T squared sub 2 over the N2 plus T squared sub 3 over the N3. So, pwede siya mag-vary depending sa problem natin kung hanggang ilan yung T and yung value ng N natin. And, ima-minus natin siya with the summation of X squared over N. Well, for the SSW or the within samples sum of squares, we have yung formula as summation of X squared minus open parentheses T squared sub 1 over the N1 plus T squared sub 2 over the N2 plus T squared sub 3 over the N3 close parentheses, or may also vary based sa problem natin. Again, yung value or yung T natin is balikan natin. The T is the sum of the values in sample, and also yung N natin na tinutukoy again is the sample of the size of the sample. To calculate na yung value natin, we have lang, di ba, the method 1, method 2 again, and the method 3. For the method 1, we can get yung t sub 1 natin tsaka yung n sub 1. Yung t sub 1 lang naman natin dito is the total number or the sum. Ito lang, 48 plus the 73,
i-add yan, ma'am.
51, 65, at saka 87. I-add mo lang siya lahat para makuha natin yung value ng t sub 1.
T1. T sub 1. Okay.
So we have na value for that is that 324. Well, for the n naman is yung sample, kung ilan lang yung sample. We have naman 1, 2, 3, 4, 5. Kaya yung n1 natin dito or the n sub 1 is 5.
5.
Then, and then next naman natin, we have naman for the method 2. Makukuha natin si t sub 2 and the n sub 2. For the t sub 2, same lang naman yung process natin. We will add 55, 8 plus 85, 70 plus 69 and yung 90 natin to get the value of 369. And again, for the n sub 2, bibilangin lang natin kung ilan lahat yung nasa method 2 natin, which is also the same lang naman siya as 5. So we have 5 samples here. And last, for the method 3, we have na for the t sub 3, add lang natin si 84 plus 68 plus 95 plus 74 and plus 67 to get the value of 380. And also for the n sub 3, same lang siya for the n sub 1 and n sub 2, which is also equivalent with 5. So kasi 5 samples lang din siya. And for the summation is i-add lang natin lahat. So we have naman dito, sabi nga natin is based siya sa problem. And dito sa problem natin, we have 3 t. I-add lang natin siya. So t sub 1 plus t sub 2 plus t sub 3. Or equivalent lang siya sa 1,081. And for the n naman natin, we have yung n sub 1, m sub 2, and n sub 3. Kapag in-add natin siya, we have the value of 15.
50. Opo,
and then yung next naman natin, sabi natin, is we also need to calculate the value of the summation of x squared. Dito sa summation of x squared, kailangan natin isa-isahin natin siya. Let's say we have dito, di ba? We have yung method natin na to. As yung value natin ng 48, squared natin to, plus yung squared ng 73, plus the squared of 51, plus the squared of 65, 87, until maabot natin yung value nito, 67 na to. So lahat to, iisa-isahin natin siya, and i-square natin siya. So kapag nakuha na natin yung value niya, lahat na summation na natin or na x squared, yung total value for the summation of x squared is 80,709. Again, pag summation of x, pwede na lang natin i-add yung all the value of t. For the value of n naman, yung total value ng n, i-add lang natin siya. And for the summation of x squared, lahat ng numbers is naka-squared and then ito total lang natin siya. Okay?
Opo, ma'am. Nakuha naman.
Ayan, sabi natin, kukunin na natin, di ba, yung value bago natin makuha yung other values. Ang requirement for the SSB and SSW is yung mga kinuha nating value kanina. Balikan ulit natin yung formula as i-recall. Ito. So yung T sub 1, T sub 2, naka-squared lang siya over yung sa N1. So meron naman tayo nakita na natin yung value nitong T sub 1, di ba? Nakuha na natin siya.
Yes,
and also for the SSW, nakuha rin natin yung value ng summation natin ng x squared. And well, for this naman is we have the value of summation of x, di ba?
Yes, ma'am.
Gagamitin lang natin siya based sa formula. Apply lang natin yung formula. We have for the t sub 1, which is the 324, squared lang natin siya over 5. Then yung t sub 2 natin, which is 369, squared lang natin siya. And over nung n2 natin, n sub 2, which is also 5. And for the T3, squared lang din natin 388 squared over yung n sub 3 natin. And for this value naman, ito yung total value natin ng summation of x. And squared lang natin siya over yung total value ng n natin, which is 15. And for the value of the SSB, we have 432.133. And for the SSW, ito yung value ng summation of x squared natin, which is 80,709. And ito yung T sub 1 squared t sub 2 squared, t sub 3 squared, and ito yung n1 natin, n2, and then n3. And then with the application of the formula, gamitin na natin yung formula, then for the value of the SSW, we have 2,372.8. And after nun, di ba, sabi natin, meron tayong formula na to get the SST natin, kukunin muna natin yung value ng SSP and then yung value ng SSW. And then i-add natin siya to get the value of SST. So therefore, when we add the value of SSB and the value of SSW, we will get the value of SST as 2,804.9333. Yeah. And next natin is the variance between the sample of the MSB and the variance within the sample. So we have na yung value daw ng SST. And di ba before pa tayo mag-start ng discussion, we have daw yung formula for the F, di ba? Na we need to get the value of the MSB, which is the variance between the samples, and also the MSW, which is the variance within the sample. So kukumpit na natin siya. And so for the formula kasi connected, halos kung mapapansin mo, ano siya, step-by-step process and connected siya with each other. As a requirement for the MSB, ito yung value for the SSB natin. Needed natin siya. Well, for the MSW, kailangan naman natin yung value ng SSW, which is na-compute na rin naman natin siya. So for the formula for the MSB, we have SSB over K minus 1. Well, for the MSW, we have the formula of SSW over the N minus K. So, given na to sa value natin, yung K at saka yung N later. Where yung K minus N and N minus K are respectively the DF for the numerator and the DF for the denominator. For the F distribution, remember that yung the K is the number of the different samples. So, dito, sabi natin is we have yung value as yung K natin as 3. Given na to dun sa sample natin, yung numerator natin, di ba? Tatlo yung binigay natin dun na method for the K. And yung SSB natin is na-compute na rin naman natin siya, which is the 432.1333. And yung 1 dito is as is lang siya sa formula natin. So therefore, the value for the MSB is 216.0667. And then for the variance within the sample, or the MSW, so formula natin again is the SSW over the N minus K. The value for the SSW is 2,372.80. For the problem number 3, ang hinahanap natin, or yun, given na dito, additional na given natin is yung use na natin ng significant level natin, which is the 1%. And yung gusto nating malaman dito is if we will going to reject the null hypothesis daw for the 4th grade, given na meron tayong 3 methods. Ayun. So, again, step-by-step process tayo. Paano natin siya isolve? Yung first natin na step is to determine again yung sa null hypothesis natin and also the alternative hypothesis natin. Since we have yung method 1, method 2, and method 3, the assumption for the null hypothesis is equal lang siya lahat for the 3 groups. Or we have here for the H sub 0, yung mean 1 natin is also equal with the mean 2, and also equal din siya for the mean 3 or the mean sub 3. And for the alternative hypothesis or the H sub 1, we have here that not all 3 means are equal, or hindi equal si mean 1 kay mean 2 and kay mean 3. And next daw natin, for the second step is to select the distribution to use. Ano ba yung distribution natin? So, for this problem, we are comparing for 3 normally distributed population. We use the F distribution to make the test. Kasi nga, ito yung gagamitin natin naman talaga, F distribution. And next natin is, we need to determine yung rejection and non-rejection region. So, before naman kasi, di ba, although ang discussion natin is focus sa normal distribution, we also have yung acceptance region and we also have the rejection region. Same with this problem kasi hindi natin ma-identify kung mag-a-accept ba tayo ng null hypothesis and also the alternative hypothesis kung hindi natin alam kung alin yung part ng i-accept natin na region and also yung part na i-reject natin yung region. For this, we need to determine yung degrees of freedom for the numerator and also the degrees of freedom for the denominator to determine na yung mismong kung saan siya covered, kung maka-covered ba siya dun sa acceptance region natin and also the rejection region. Ayan, compute lang ulit natin kanina. Ito yung naging computation natin. For the numerator, we have k minus 1 for the computation or equivalent to 3 minus 1 equal 2 lang siya. And then for the degrees of freedom for the denominator, we have n minus k or also equivalent to 15 minus t or 12. And hanapin lang natin siya sa table where yung numerator natin again is the 2 and for the denominator is 12. So hanapin lang natin yung katapat niya dun sa table natin ng value natin is 1% or we have yung 0.01. And yung value for that is the 6.93. Ito yung nasa table na natin ha, hindi na natin binalikan yung table natin. Pero ito siya yung katapat lang nung 2 and 12 natin. Or yung DF natin, again, DF is equal to 212. 6.93. And yung graph natin, which is yung F distribution natin, ganito yung itsura niya. Itong area na to, which is yung hindi highlighted, ito yung area ng acceptance region natin ng for the H sub 0. Kapag daw pumasok dito sa area na to, yung value natin for the F, ito yung magiging i-accept pa rin natin si H sub 0. Ang i-reject natin is si alternative which is yung H sub 1 natin or the alternative hypothesis. Kapag naman yung makakompute natin later is pumasok siya dito sa mismong value natin na to, itong part na meron tayong highlighted na area, i-reject natin si H sub 0 or yung null hypothesis yung mare-reject natin. And then yung critical value natin again is the 6.93. Yung in between. For the value naman, for the step 4 natin, we need to calculate the value of the test statistic. Yan, we compute the value of the test statistic. Ito yung kanina natin kinompute, yung unang-una natin ginawa for the problem number 2. Di ba? Naalala pa? Yung value natin ng 1.09. So yung 1.09 natin is nasaan ba siyang value? Mas malaki ba siya sa 6.93 or mas mababa siya sa 6.93?
Mababa po.
Mas mababa siya. So, kapag enough natin, let's say, ito yung value natin as, ayan, ito yung 6.93 natin, let's say, dito yung bandang 6 natin, for example, 6, 5, for example lang, 3, 4, 3, tapos 2, and, for example, ito yung dito yung part natin ng 1.93. Itong part na to is, ito daw yung F natin na 1.93. So, yung yung value 1.0, ay 1.09. Correction lang. 1.09. Ayan. So ito yung value ng 1.09 natin and ito yung value ng 6.93 natin. So ano yung pwede natin maging conclusion ngayon? Yung value daw na na-compute natin for the F kanina is 1.09. So ano yung magiging conclusion natin? I-accept ba natin si null hypothesis or i-accept natin or i-reject natin si null hypothesis based dito sa given natin?
I-accept, ma'am.
I-accept natin sino? Sino ang i-accept natin?
Null hypothesis.
Null hypothesis. Okay, tama siya. Kasi yung value natin ng F natin is nandoon siya sa area ng itong area natin na to na ang sabi dito is do not reject si H sub 0 or we need to accept the H sub 0. Yan. So therefore, gagawa tayo ng decision based dun sa graph natin which is because the value of the test F which is yung 1.09 natin is less than the critical value of 6.93, it falls in the non-rejection region. Hence, we fail to reject the null hypothesis. So in short, since hindi natin i-reject si null hypothesis, ang conclusion natin is lahat 'di ba? Sabi natin yung mismong ginawa natin kanina, yung null hypothesis natin, ang assumption natin lahat ng mean natin is equal. And for
Yes,
the
yes.
alternative hypothesis natin, hindi sila lahat equal. So kung hinaccept natin si null hypothesis, therefore, yung tatlong mean natin or tatlong given natin kanina ay equal siya. Or in other words, ayan, equal siya. So kasi accept natin si null hypothesis. Or in other words, the three different methods of teaching arithmetic do not seem to affect the mean score of students. The difference in the three mean scores in the case of our three sample occurred only because of the sampling error. So, ayun, balikan natin. Balikan lang natin yung null hypothesis natin. Ito yung i-accept natin na yung mean score ay lahat equal. Based doon sa naging value natin, which is 1.09 as yung F natin.